In this video, I'm going to be showing you the three-sum problem. It's number 15. It's a medium in LeetCode. And I'm going to be showing you two solutions. One is time limit exceeded in LeetCode. It works on my computer. Then another one is an optimization that just looks really nice. It's a great solution. So given an array nums, return all triplets, nums I, nums j, nums k, such that I does not equal j, I does not equal k, and j does not equal k. So none of them are the same. These are three distinct elements within the array. And nums I plus nums j plus nums k equals 0. Notice that the solution set must not contain duplicates, meaning if we do -1 plus 2 plus -1, and then let's just say this array is longer and there's actually another -1, and then we get this -1, we get this 2 again, and we get a later -1. We don't include both of those arrays. We just include the -1, -1, -2. Once this is here in the output array, we never add another one like it. So you can see, let's look at the first example. We have this array here. It's unsorted, and the output is -1, -1, 2, because -1 plus -1 plus 2 is 0. -1 plus 0 plus 1 is 0. And you could see that here. Feel free to pull up the problem, pause the video, and check it out and read through it if you'd like to do that as well. And then nums.length is anywhere from 3 to 3000. So we know there's going to be at least 3 elements in here. And at max is going to be 3000. And then each element is going to be anywhere from -100,000 to +100,000. And so the first one is just a triple nested for loop. It's as brute force as it gets. Like I said, it works on my computer, but it's not going to work in LeetCode. So let me go ahead and just give you an example of what we're going to be doing here. So we're going to initialize, we're going to have I, we're going to initialize j, and and we are going to initialize k on the third one. And so we're going to be targeting each one. Nums I, nums j, nums k. In this one, we have 1 plus -1, so 0 plus 1. These three combined equals 1, so that doesn't work. Increment k. Now we have 1, -1, 0. This is going to equal 0, and so we're going to add this array to our output array. Keep going. -1, -1, 1. -1 plus -1 is -2 plus 1 is -1, so that does not equal 0. Keep going. And then when this k gets to the end of the array, we're going to increment j, and we're going to start k here. And so we're doing the same thing with j moved 1 position forward. Then when k gets to the end and we analyze all those, same thing. J is going to move forward. K is going to move to a position just before j. And then when k makes it all the way to the end and j makes it all the way to nums.length -1, then we're going to increment I by 1. J is going to move back to I plus 1. K is going to move back to I plus k. And we're literally testing every single scenario. Now, one thing we're going to need with this one is a set. We're going to need a set to keep track of duplicates. So once we encounter -1, -1, or -1, 1, and 0, that equals 0, but then we're also going to have 1, 0, and -1 here. And so we need a way to not include the second occurrence of this. And so we're going to use a set to do that. We're going to test to see if they equal 0. If they do equal 0, we're going to create an array called triple or triplet array. And then we're going to turn that array into a key, and we're going to test to see if that key has been set in the set. And if it has been, then we're not going to add it to the output array. And if it has been, then we aren't going to add it, and we're just going to keep going. So let me go ahead and comment this out. I'll go ahead and type the pseudocode. So create output array, create set, iterate over I. So this is going to be for I until length -2. Then we're going to iterate over j until nums.length -1, because we know with I we're only ever going to make it here, with j we're only ever going to make it here, with k we're going to go to the end every single time. And then iterate with k until nums.length. Then we are going to test to see if the 3 elements equal 0. If they do equal 0, then we are going to create the array, the triplets array, because we are going to, if you look at the problem, we are going to be outputting a main array with subarrays every time we find 3 elements that equal 0. So create the triplets array. We'll actually sort that too, just to make it easier to check the set later on for duplicates. We'll create the key using join, separated by commas. And then we will test to see if the set already has the array. Actually, if the set does not have array key, then we're going to push our triplet array onto the output array and add the key to the set. And then at the end, we'll just output or return our output array. Return output. There we go. So here we will go ahead, create the output array. And if you have any questions about any of this stuff, feel free to leave something in the comment. We'll call it scene equals new set. So we can't have any repeat characters inside of this array. That's what a set is. A set is just an array you can't have repeat characters inside of. Then we'll create our for loops. Let I equals 0. Well, I is less than nums.length -2. Let's go ahead and just create, since we're going to be using this several times, nums.length. So we'll just do n -2, I++. All right, so that's our external loop. This is our second for loop for the second character. J equals I+1. We always want it to start just one ahead of I. N -1. It's never going to go any further than the second to last element. J++. All right. And we got our last one here. Boom. All right. for let k equals j plus 1, always going to start 1 ahead of j while it's less than n, k plus plus. All right, so I equals 0 while I is less than n minus 2, I plus plus, j equals I plus 1 while j is less than n minus 1, j plus plus, k equals j plus 1 while k is less than n, k plus plus, perfect. And then we'll test to see if we have a match that's equal to 0. So if nums I plus nums j plus nums k equals 0, then we'll create our triplets. So let triplets equals, and we have our array here. So nums I, nums j, nums k. Okay, so that's that array right there. And then we'll go ahead and we'll sort that array in ascending order, put that in order. So if it's 1, 0, -1, it'll end up as -1, 0, 1. So if we ever encounter those three same characters ever again, then we know that it's going to be in the same exact order. We're going to let our key equal triplets dot join, and we'll put a comma in between. So that's just going to take this array, create a string with it based on the values inside of it. So let's just say it's -1, 0, 1. We'll end up with something that looks like -1, 0, 1, a string. And that's our key right there. So if that key is ever found inside of our set, then we know we're not going to store it. And then if scene has key, well, if it doesn't have key, then we'll run this code. So we'll take our output dot push triplets. All right, and we will do scene dot add key, and that should be good. So we have our key here, triplets dot join. We're sorting that right there. If this key does not already exist in the set, then we push the triplets, this array right here, sorted, onto the output array, and we add the key to the set. Then if we ever encounter this same array ever again, then it's not going to add it twice, and then we output that. And all right, let's test this bad boy out. 1.js, we got -1, 0, 1, empty array 0, 0, 0, and we're looking for let's see. So our first example, we got -1, 0, 1, which that's not one I used. Let's go ahead and use this one too, just so we could see, since that's one of the built-in cases. So -1, 0, 1, -1, -1, 2, -1, -1, 2, -1, 0, 1. Perfect. The second one is an empty array, and the third one is 0, 0, 0. Perfect. So I already tried this solution in LeetCode. It doesn't work, obviously. With these triple nested loops, you're looking at an O of n cubed solution, which is just ridiculously inefficient, not something you're going to want to use. And so we're going to check out an optimized solution in another file. So that's that one. Let me make it a little smaller for you so you could see it all on one screen. Feel free to get a screenshot of that there. Definitely not the one you want to use with this problem, and this isn't even a massive problem as far as the size of the array comes. So if you use something this inefficient on an array that's even bigger, it's not going to be good. And so, all right, let's go to the next one. So the next one is we're going to do something similar with a few optimizations. So with this one of the first things we're going to do is actually sort the array. So we have -1 3 times. Then we have 0 0. Then we have 1 1 1. So it's going to actually end up looking like this. It's going to be sorted. We want to sort it first. This is going to make optimizing for if we ever encounter another one of the same digits. It's going to make just moving to the next one quicker. We're not going to have to do all of the tests. And yeah, so once we have it sorted, we're basically going to create an I. We're going to create left, and we're going to create a right. And so we're going to be able to take -1, -1, 1. We see that that is less than 0. So we're going to be able to test and just see, is it 0? No, it's not 0. Is it less than 0? Yes, it is less than 0. So we increment L. Same thing, -1, -1. We see that it's less than 0 again, and so we increment L. This one, we see that it does equal 0. We have -1, we have 1, and we have 0. And so we see that it's equal to 0. And since it's equal to 0, then we're actually going to add these 3 to the output array. We're going to increment L. We're going to decrement R. And then we're actually going to test the value of L. So if we see that the value here is the same as the value here, then we're going to increment L until the previous value is different. And then same thing with this. We are going to test to see if the previous value of nums R is the same. If it is, then we decrement it. And once L is not less than R anymore, then we start over. So what we're going to do is we're going to move I. We're going to move that, just I plus 1. We're going to move R back to the end of the array. Now we're actually going to have a check in the beginning of the for loop too, and just see if this I here is the same as the previous I. And if it is, we're just going to continue. Because we know if we have a -1 that with the L and the R, we've already found, if there's a match, we already found it. If there's not, then there isn't. We've already checked this -1. And since we've checked every element with L and R, we know that if there is a match, we found it. If not, then there isn't. So we go ahead, move the L there. We see that it's the same anyways, so we just move it again. And so we're able to skip a few without doing all the checks. We know if the previous values are the same as the current value of I, then we could just skip to the next one. So we start here. We see 0, 0, 1. That's going to equal 1. it's greater than 0. So we move R. We see that R is the same as the previous value of R, so we keep moving it. Same as the previous value, keep moving it. And now L is not less than R, and so we start over. Boom. And actually, we could build in an optimization. I haven't built that in yet, but once I gets to a positive value, we could just cut out right there, essentially, because we know that if I is at an element that's greater than 0, L is also at 1 that's greater than 0, and R is also at 1 that's greater than 0, so we're never going to be able to get 0. But that's a later optimization. So let's go ahead, do the pseudocode. If you have any questions about this problem here, feel free to ask them. I'll do my best to answer for you. And so we're going to sort the array. We'll do the same thing, create a variable to represent the length of the nums array. And we'll create our output array. Then we'll begin iterating over array using I, so that's going to be our for loop. The check that we're going to have to see if the current position nums I is equal to the last position is going to be in the beginning of the array, but so we'll do if nums I is equal to nums I minus 0, but we'll also do if nums I is greater than 0, if I is greater than 0 and nums I is equal to nums I minus 1, because we don't want to do it while I is in the first position, because we know that there's nothing before it. So check to make sure current and previous nums I are distinct. Okay. Check to make sure I is at a position greater than 0, and okay. Then if it is distinct from the previous, let's just say we're here, if it is different or it's at the first position, then we want to find our left and our right position. So initialize left pointer to I plus 1. Initialize right pointer to n minus 1. And then we'll basically close in our left and right pointers until the left pointer either hits the right pointer or passes it. So while the left pointer is on the left of the right pointer, we will test to see. Actually, we'll just create a sum variable. Using the 3 elements. And then there's 3 cases. If the sum equals 0, else if the sum is greater than 0, else the sum is less than 0. And if it's greater than 0, then we want to decrement right pointer. And if it's less than 0, then we want to increment left pointer. And then if it's equal to 0, we want to store the array. Well, it's like a triplets array. We're just not creating one. Triplets array in the output array. Increment left pointer by 1. Increment or decrement right pointer by 1. And then we want to do the check where if the left element is equal to the current left element, then we'll continue incrementing. So while left is on the left of right and current left is equal to previous left, just increment left. And while left is on the left of right and current right is equal to previous right, decrement right. And that should be good right there. And then we will return the output array. All right, that looks good. Let's go ahead and type the code. So the first thing we're going to do is we're going to take this array. We're going to sort in ascending order from least to greatest. We're going to create our output array. And we're going to create our length of the nums array. Nums.length equals n. We'll begin iterating over. So we'll start at the 0 position while I is less than n minus 2. You know I is never going to make it past the second to last element because we still have to account for the left and the right. And then we'll increment. So starting at 0, incrementing 1 every single time, going to the second to last. Perfect. All right. Check to make sure I is at the position greater than 0. So if I is greater than 0 and nums I is equal to nums I minus 1, just continue. Just skip going. Because if we have like in this array where it's sorted -1, -1, -1, if I was first on this -1, we know that on the next iteration when I gets here, we could just move I here, then we could just move I here. We don't have to do all the processing because we already know if we found a match for -1 with L and R, we're using L and R to analyze the whole rest of the array. And so once we found the matches for this one right here, we found all distinct matches with L and R. So we're good to go. We could just skip it. So we'll initialize our left to 0. Initialize our right to n minus 1. We're going to be starting our left always at I plus 1. It's always going to be 1 ahead of I, and this is always going to be the last element of the array. So we're slowly just closing in. Then, while left is less than right, if it ever comes to the point where left passes right, then we know we need to just increment I. We've already checked all of them. If left passes right, we know we've checked everything on the right side of I has been checked. Okay. So create a sum variable. Let sum equals nums I plus nums left plus nums right. That's going to give us the sum of these three. We're looking for 0. That's what we want our sum to be. So if sum equals 0, then we're going to execute this code. Else if sum is greater than 0, if the sum is greater than 0, then we want to decrement right. Else we know that the sum is less than 0, so we want to increase left, because increasing with the sorted array, increasing left will increase the sum with each iteration. All right, so if sum is equal to 0, then we will do output dot push nums I, nums left, nums right. So we're pushing a new array onto the output array that consists of 3 values: nums I, nums left, and nums right. Then we go ahead, increment left, go ahead, decrement right, and then while left is less than right and nums left is equal to nums left minus 1, increment left. We know if we ever encounter a nums left that has the same value as the previous left, that any combination possible with this new left has already been made with the previous left, so there's no concern there. You could just keep incrementing left until you get to a different value. And then we want to do the same thing with right. So while left is less than right and nums right is equal to nums right plus 1, because the previous is on the right of right and the previous for left is on the left, because right is moving to the left, left is moving to the right, so the previous will be on the opposite side. And then we will decrement right. So we'll decrement right until we find a distinct character there. And that's self-explanatory. Okay. So we have that. That's self-explanatory. All right, so let's check. We're sorting the array. We're creating our output array. We have our length. We're iterating over the array from 0 to n minus 2. We're checking to make sure that when we're at the first element and every element onwards, that the previous nums I is not equal to the current nums I. If it is, we just continue because we know we already accounted for any equal values. Then we initialize left to I plus 1. We're always starting left at just 1 in front of I. We're always starting right at the end of the array, and then we're working them inwards. Left pointer is moving to the right, right pointer is moving to the left. Once left reaches right, we know we've accounted for every element in the array. So while left is less than right, continue doing this. Find the sum, nums I plus nums left plus nums right is going to give us the sum of these 3 elements in the array. Then we're going to test if sum equals 0, run this code. If sum is greater than 0, then we know we want to take the higher numbers and we want to decrement and move to lower numbers so that the sum on iterations that come afterwards is lower than the one it is now. And if it's not equal and it's not greater, we know it's lower. So we increment left and we know it's lower. So every time we move left to the right, the sum will actually be increasing. And so we increment, if the sum equals 0, then we take nums I, nums left, nums right. We place those 3 elements or values inside of a new array, push that array onto the output array, and we should be good to go. Increment left, increment right, moving both pointers inwards towards each other. And then while left is less than right, we're checking to make sure that the new num's left value is not equal to the previous num's left value. If it is, we just increment left. We've already accounted for that value. And then same thing with right. While left is less than right, we check the current right. If it is equal to the previous right, so the element that's on the right of it, then we just decrement right. And we keep doing that until we find a distinct value. And yeah, that looks clean. So I was testing that. Let's go ahead and 2.js. And we are getting -1, 0, 1. And so that's with our previous one. Let me go ahead and get this test case. This is the one they're actually testing for in LeetCode. So there we go. -1, -1, 2. And then -1, 0, 1. So similar there. Let's test it out in LeetCode, see how it is. All right. Accepted. Time limit exceeded. Ah, perfect. Awesome. Awesome. Looks good. So if you have any questions about this one, feel free to ask. I'll do my best to explain them to you. Or if you have other solutions where you think like, hey, I have a better version, I have an optimization. There's one optimization I could think of right now where I'll let you guys implement it because it's an easy solution. But basically, when you increment I, if num's I is greater than 0, like the actual value in the array, like let's say num's I equals 2 and it's a positive value, we know that num's left and num's right are also going to be positive values, and that there's no possible way that we could get to 0. That every iteration now from this point on, where we finally reached a positive value of num's I as a positive value, we know, since we sorted the array in ascending order, so least to greatest, that if num's I is a positive value, we could just break. We could just break out of here and just return the output. So once we reach a positive value for num's I. So go ahead, implement that. It's one line of code. It's super simple. It's just a check in the beginning, and it'll definitely be a small optimization,